Okay, let's see the answers. So, whenever we do A greet D, we say hello animal. All right, so the idea here is that the animal class, it has a greet method, and it's inherited by the dog class. No surprise there. How about sniff? Well, if you're sniffing a dog, or if you're sniffing this right here, it seems like what I said earlier, right? Because the dynamic type of this A variable is dog, and we're overriding the sniff method, well, in that case, it's dog sniff animal, right? This is just like what we saw, where if we have an S list in a list memory box and we call the print method, well, we're going to call the S lists version. Okay. Now we get to D praise D. So in this case, we have a method called praise, and we have a dog calling praise dog. So we get you are cool dog. And then lastly, we have a.praiseD. And in this case, somewhat surprisingly perhaps, the answer is you are cool animal, not you are cool dog. Okay. Now, maybe you already got that, but maybe not. I know a lot of students get to this and they say, how is that possible? Why did this just happen? And I think one way of thinking about it is that this praise method, it's overloaded, not overridden. Notice that this is not the same method signature in the dog class. It's not praise animal in the dog class. It's praise dog in the dog class. This is actually a totally new method. So it's not overloading or overwriting. It's overloading the other praise method in this dog class here. Okay. Now, while that technically is the answer, there's a totally different way of thinking about dynamic method selection that if you felt uncomfortable with this, that it may help understand what's going on. Okay, so this alternate approach, this is a different viewpoint for dynamic method selection, is that it's actually a two-step process. Okay, the first step is something that happens at compile time, and the second step is something that happens at runtime. Now these two steps, they obey rules that are easy to apply. Once you get them, it's not hard to do at all, but it takes a little bit of time to understand. So we're going to redo that exercise now in the flavor, or now with these two rules in mind, this two-step process in mind. So the first step is that at compile time, we pick the signature S of the method that we're going to call. Okay. And S is going to be decided, and this is the key point, using only the static types, because it's done at compile time. We don't know the dynamic types. Then at runtime, and this is a bit of a mouthful, the dynamic type of the invoking object uses its method with that signature S. And by invoking object, what I mean by that is the object whose method is invoked. So if I do d.jump, the invoking object is d. Okay. So let's think about this here, and by doing that same exact problem, but now thinking about it as this two-step process. Okay. So we're gonna do an exercise to understand that first rule. Okay. So same deal as before. I still have the exact same class and interface. But this time I only want you to do the first step, which is to pick the static types, okay? Now remember that this rule is we pick the signature based on only the static types, and in case you're fuzzy on what signatures are, remember that the signature consists of the method's name and the number and the type of its parameters. Okay, so when I call a.greetD, just based on the static types, what signature is going to get used? I'll spoil the first one, which is greet animal, okay? We're going to use greet animal. All right, so fill out the rest of these and just write the signature of the method. So when I do a.sniffd, we say animal, right? We look in the animal interface because we're using only the static types. And we use the dog type over here, and we say, is there a method here called sniff which can accept a dog? And the answer is yes, right? This sniff animal method. So it's going to be sniff animal A. Now I should note there are actually two different sniff animal methods. There's one in the dog class and one in the animal interface. And Paul Hilfinger, who also teaches this course at Berkeley sometimes, he calls these a dynamic method set. Just throwing that term out there. All right. Now if we do now d.praiseD, in that case, we look in the dog class, right? Instead of the animal class. And why? Because we're only considering the static types. So we ask dog class, do you have a method which can take a dog? And it actually has two methods that can take a dog. And so it's going to pick the most specific one. It's going to say, I want to use praise dog. Then lastly, when we look at a.praiseD, In that case, we look at the animal interface and we say, do you have something that can accept a dog? And it does. It's called praise animal. This is the underlying trick. If you felt confused before about why the answer was what it was, this is why. At compile time, d.praiseD chooses the signature praise dog A, and at compile time, the compiler chooses praise animal A. And the reason is, remember that it's only looking at the static types. So for the dog class, it has these 4 choices. For the animal interface, it only has these 3 choices. So it's going to use praise animal. Okay. All right. So we've seen this process. And so now what we're going to do lastly is do the second step. So at runtime, recall, the dynamic type of the invoking object is going to decide which method with that signature gets used. Okay. So we saw how to do a rule 1. Now we're going to see how to do rule 2. All right. Now I'm already showing the results of rule 1 on this slide. And so what I want you to do now is apply rule 2. That is, the invoking instance here is of dynamic type dog. Okay. And so you'll want to use the greet method from the dog class. We're going to use the one on this side every time, because the dynamic type for A and D are dog. So try it out. So the first one is, well, the invoking object is A. The dynamic type of A is dog because it's a new dog. And so we're going to use dog's greet method, and we get hello animal. Okay. How about sniff? Same deal. Well, now there's actually 2 different sniff methods, but the dynamic type of A is dog, so we're going to use this one. If the dynamic type of A had been animal, if this said animal A equals new animal, we would be calling this method on the left. But we're always going to use the one on the right because both A and D, our invoking instances, are of dynamic type dog. Okay, when we get to praise dog, okay, in this case, we're going to use the dynamic type dog's praise dog method. And so we get you are cool dog. And then lastly, we're going to use the dynamic type dog's praise animal method. Okay, so we're going to call praise animal over here, and we get you are cool animal. There you go. So we're calling the one on the right. Okay. All right, that's it. So that's basically an alternate way of thinking about this. And if you really, really understood this example, you should be able to handle any such scenario like that. Think of it as a 2-step process, and I think you'll see good results.